Black holes are the strangest and most mind-blowing objects in the universe.
They're a place where the known laws of physics seem to break down. It's basically an area of total mystery.
Scientists are mostly baffled by them, but black holes seem to be an essential part of most galaxies, and unlocking their secrets could be the key to understanding the very fabric of our universe. So what do we know about black holes? Scientists have long predicted black holes as a theoretical possibility. For most of the 20th century, they assumed they must exist. But it wasn't until near the end of that century that they developed the methods to properly detect them. Then, in 2019, a global research group made a huge leap forward, the first ever image of a black hole. Finally, after years of wondering, here was direct evidence that they do exist. Admittedly, that image is a little less dramatic than the fiery, tornado-like vacuums we see in films. Scientists are getting ever more details about these weird cosmic objects. They've even discovered what they sound like. But with still so much we don't understand about them. Let's start with what we do know.
A black hole is a region of space that is so dense, there's so much gravity that nothing, not even light, can escape.
We know there are several types. First, there are stellar black holes. They're formed when a massive star implodes and its outer layers explode in a supernova.
We see these supernovas all the time. They're some of the brightest objects in the universe. Sometimes a supernova can be brighter than the entire galaxy that it's inside.
If the star is big enough, the remains of its core will collapse into an infinitely tiny, dimensionless point, and a stellar black hole is born.
There is so much gravity condensed into that point. We're talking several times the mass of the sun condensed into a point that's smaller than the smallest bit of an atom. You imagine it's very dense. It basically rips space-time at that point, creates a hole. So it's a point of infinite density. And that point is known as a singularity.
We know that stellar black holes can have a mass 3 to 20 times greater than that of our sun. They sound gigantic, but this is nothing compared to supermassive black holes. These can be millions or even billions of times the mass of the sun.
No one really knows where they came from initially, or not yet anyway, and it's thought that most galaxies, probably all galaxies, have a supermassive black hole at their centre.
So what about the reputation that black holes are cosmic hoovers that suck up anything and everything within reach? We know this isn't entirely true. Not everything gets drawn in if it stays far enough away. But if an object does get too close, and it crosses what's known as the event horizon around a black hole, it's reached a point of no return. It's pulled in towards the centre, the singularity, where gravity is infinite. At least, that's the assumption.
What's going on in that point to create that much gravity? Well, we know that if you have huge amounts of matter, matter creates gravity. If you have huge amounts of matter in a single point, there's going to be lots and lots of density of gravity there. But that's about it. The singularities are probably the most mysterious thing in physics. They're kind of like a word for something that we just do not understand.
Despite pop culture depictions where the hero escapes the pull of a black hole,
I'm just towing you home. Gravity schmavity.
in reality, things probably wouldn't end well.
So what happens, people think, is if you got close enough, then each atom will be drawn out one at a time until essentially your entire ship, and you on it, I'm assuming, would be drawn out into a line of atoms, essentially a piece of spaghetti.
Scientists actually call this spaghettification. It's been observed in stars as they cross the event horizon, dragged in by the black hole's unbeatable gravitational attraction. Even light can't escape a black hole. This means, by definition, they're invisible. So how do scientists detect them?
Black holes do have an impact on the space around them. They might have gravitational effects on other objects to make them rotate around the black hole.
It's these telltale signs around a black hole that help identify them.
So if they go past a star, then they will deform that star because they'll try and pull material away.
In 1971, it was these gravitational effects and radiation that led astronomers to identify a black hole for the first time. They determined that X-rays were coming from a bright blue star, orbiting a strange dark object. This radiation showed stellar material was being ripped away from the star and consumed by a black hole they labelled Cygnus X1. Spotting patterns of radiation like this is still essential in detecting black holes today.
Around the event horizon, in the many, many billions of miles around the event horizon, gas and dust is very strongly affected by the gravitational effect of the black hole, but doesn't get sucked in. So it will spin around and around the black hole. Lots of energy will go into it. It might radiate in lots of different colours, including X-rays and gamma rays, which are the most energetic forms of light.
So when we look at the images created by the Event Horizon Telescope collaboration, it's the light from the material zooming around the black hole that we see.
It matched the models that they'd created of what light would look like if it was surrounding a black hole, but also then bent by the gravity of the black hole.
In 2022, the Event Horizon team released their second image, showing the supermassive black hole at the centre of our galaxy, the Milky Way, Sagittarius A star, 27,000 light years away.
If you've ever seen Interstellar, the film, they have a CGI of a black hole, which was actually physically correct. There are other things about that film that aren't quite right about black holes, but the way it looked was actually based on real physics. And that's what they saw in these pictures, essentially. A very fuzzy version of it, not as high definition as Interstellar, but that's what a black hole would look like.
Sagittarius A star appears in the sky as about the same size as a donut on the moon, so it looks very, very small. Both images made by the Event Horizon team were groundbreaking, providing solid proof that black holes do exist. But many mysteries remain, like where does matter swallowed by a black hole really go? According to general relativity, Albert Einstein's theory of gravitation, nothing can escape a black hole, so everything it consumes is destroyed. In 1974, Stephen Hawking theorized that black holes emit a tiny bit of radiation, now known as Hawking radiation. This radiation causes a black hole to gradually lose mass, and after a very, very long time, eventually disappear.
It appeared that all the information about what fell in the black hole was lost.
But this clashes with another fundamental of physics, quantum theory. It states that even if an object is transformed or destroyed, its quantum information, details of each particle inside an object and how it behaves, can never be lost. This disagreement is called the black hole information paradox.
These two big theories of physics don't agree with each other. What physicists have been trying to do for decades now is to find ways to connect these theories up. In other words, to find another physical idea which encompasses both of them.
Physicists could be close to unlocking this mystery, which may require a new theory altogether.
The only way to understand some of the biggest mysteries in the universe about what the universe is made of and where it's going in the future, not to mention where it came from, these are things that you can only understand if you have a more universal rule of physics, which we know we don't have. The thing that we're looking for sits in the middle of the black hole. So if you can find out what's in the middle of the black hole, you've solved physics, basically.
Well, maybe not all of physics, but probably some of its most enduring questions. This is why black holes, in all their paradoxical, mind-bending glory, are so important. They could help not only further our understanding of the most fundamental rules of physics, but might be the key to discovering more about other weird, mysterious parts of the universe, including the beginning of it all, the Big Bang.
I'm Alok Jha, science correspondent at The Economist. To read more on this topic, please click on the link opposite. Thanks very much for watching, and don't forget to subscribe.